So here we are. We were working through this problem yesterday. We're trying to find the area under 3x. And if when we graph this, you'd be like, oh my God, Holloway, why are we doing it this way? And I promise it's because not everything is going to be as nice as 3x. Like we start with the nice ones. So we are doing this first one using the left endpoints, and we have this sweet generalization. We worked through all this logic stuff and saying, well, here's the first one, here's the second, and we will like summarize all this in the end. But what we wound up seeing is that if I want the left endpoint, I have to choose 0 plus a delta x away, and then to keep my index straight, I use this fancy I-1 technique. Now, we'll get more practice, so if that is like really fast during the review, that's reasonable. Okay, we did all that. We found delta x. We found what each c sub I will look like, each right endpoint. They'll all have this form as long as we start at I equals 1. And then we found f of c sub I, and we cleaned it up. Kind of. We cleaned it up more here. So we started working out our sum, the sum from 1 to n of all this. We did a little bit of algebra. We got here. And then we recognized that we had the summation of a difference. And notice that it should be the difference of the summations. So we're jumping in here. Our first one, and I like this factorization, we factored all these pieces out, and then we split it up. Now, for those of you that said, I'm not sure what to do or I didn't know what to do, I get it. It's new stuff. But Rafa, what did I make you do? If you go back one page in your notes, and I think it will legitimately be one page. I'm going to switch to red since we're switching days. One page in our notes, we had a few formula. What were the formulas that we wrote down yesterday? We said, here are blank rules. We have some rules, right? For sums. And I like the stupid play on words there. I like to call it some rules. But, okay. If only we had a way to expand out the sum from I equals 1 to n of I. What the Gauss should we do? Oh, this is n times n plus 1 all over 2. That's how this sum works out. Minus, and I'll switch colors just so we can pick them out easier. This is the sum of a what? A constant. And what does that turn into? N times the constant, right? And our constant just happens to be 1, so it's just n. Everybody okay with what we've done here? Okay, welcome to Algebra Land. Now we just get to clean it up a little bit. I'm open to suggestions. And I don't care which way we go. Whoever takes the first step, though, we're probably going to go with your route. So if you like the way you did it and you're comfortable with the way you did it, now's your time to speak. Or I'm going to grab the calculator, and it's going to be somebody's time to speak if we don't get a volunteer. The question at hand is, how do we deal with the algebra? And I know everybody in here can deal with it. I heard distribute. What do you want me to distribute? Like, are you talking do this distribution, or are you talking do this distribution? The second one? Okay, so let's clean it up a little bit. We'll take small steps with our algebra. We get 300 over n squared. And then this part, we'll come to love this eventually. But we get n squared plus n over 2, because all I've done is distributed here. Minus, do you want me to make a common denominator? You would, maybe? Okay. I don't know that we have to. What do I multiply this by? Clever choice of 1. 2 over 2, so it's minus 2n over 2. Okay. All I've done is common denominator with a common factor of 2. Okay. Little steps here. I'm going to combine this into one single expression. We get 300 over n squared times a whole bunch of stuff over 2. And by a whole bunch of stuff, I mean, what is this stuff? N squared minus n. Okay. Anything else algebraically that you just want me to do? Like, I'm just not really making choices here. I know what I would do, but what would you do? Abigail, what do you think here? What's your next intuitive thought? Distribute this in. So we can. Anybody have a different suggestion maybe? Okay. We'll roll with it. I'm good with that. So we get 300 n squared minus 300 n all over what? 2n squared. And maybe I would have done something different, and maybe we'll do something different if we see another path through this, but this is allowed. Anything else? Any part of this fraction simplify. Factor, what do you mean? So it's almost going to feel silly. Can I take a 2n out of the numerator? Why would I choose 2n? Because it's going to divide out, right? So if I take a 2n out, it leaves behind 150n minus 150. And that's all over 2n squared. Okay, for this, I think we can all agree that the 2's can cancel, or divide out is the real language. And then I don't remember, I think that we've done enough math together that you've seen me do this. Instead of rewriting everything, I just cross out that n and that n from the square. Okay, we now have this lovely expression, 150n minus 150, all over n. Anything else that we could clean up if we wanted? Okay, if we say no, I'm fine with no. Now, what, and this is a big question. I'm going to give you guys like 60 seconds. I want you to do the whole rock, paper, scissors, or do you want to play the even odd? Have we done the even odd thing in here? Okay, so check it out. You need somebody to work with. So if you're sitting somewhere on an island by yourself, I need you to physically stand up and move so that you work with one other person, not a group of 3, one other person. So Mickey, it's easy to just go work with Bea. And here, okay, we could do rock, paper, scissors. That's fine and dandy. Well, I'm going to do one round of this. You guys can decide amongst yourselves who calls the answer. We're going to play even or odd. That's it. Abigail, we're going to play around and we're going to demonstrate this. Now, there's an interesting game theory question behind what we're about to do that is outside the scope of this, but there's a really cool idea that applies here. All that we're going to do, I have 5 fingers on this hand. Do you also have 5 fingers on your hand? Perfect. Okay, hide it from me. You can put it behind your back or under the table. I don't care. Hold up some number of fingers. And it's just me and Abigail playing right now, but everybody else is joining in. I appreciate it. Hold up some number of fingers. Do you have a number of fingers up? Do you want even or odd? Wait, is it even or odd? No, not your number. Just give me even or odd. Okay, don't change your number. She guessed even. I haven't changed my number. Hold up your number. 2 and 3 make what when you add them? Odd, which means Abigail was wrong. And like, it's okay just to decide who wins. We're just saying between you and your neighbor, decide who's picking. And you know what? I'll decide. This side guesses. So Rafa, JJ, Bea, Abigail, and Leanne Mar are going to do this one. Sorry, you asked me not to. I just saw the opportunity. Okay, you're going to do a round of even or odd. Left side guesses even or odd. If you are correct, you get to choose whether you're about to describe what this expression means or whether it's your neighbor. You get 60 seconds to describe it. If you are the person describing it, the other person, 60 seconds, they can't speak. They can give facial expressions and stuff. Cool. 60 seconds, describe what we've just found. Cool. Play a round of even or odds. See who wins. So whether you're doing the even or odd thing here, for those of you that are traveling, what I want right now is for you guys to discuss for a moment is what does this last expression that we arrived at, what does this mean or represent? Okay, so with that in mind, we'll answer this question, but if you're watching this on the road, please go ahead and pause it now, talk for like 60 seconds, see if you guys can come to a conclusion, and you will see or hear the class discussion that we come up with in 3, 2, 1. So nice job, chat. Lots of good responses in the chat. Okay, so here we are. What does this expression represent? Now, I heard a lot of people talking about area and a lot of people talking about limits and stuff, and we are going to take the limit here in a minute. But right now, what did n represent all the way from the beginning of this problem? The number of rectangles. We got this expression by adding up a bunch of rectangles, right? Now, if I wanted to add up 5 rectangles, what would I plug in for n? 5. This expression is very specifically going to be the area using how many rectangles? N rectangles, where all we would have to do is just pick a value for n and plug it in. Now, luckily, this has been just drilled into your minds the last few days. what's the best, how many rectangles make the best estimate? How on earth do I make, I can't just plug in infinity, that feels weird. We can use infinitely many rectangles by taking the limit. Love it. And I think that was Bea, so nice job there. Okay, now, and this is the last part of the problem, and I know that this feels like a marathon awful mess. It will not as we get a little practice with it. The first run through is always the roughest. Now, take the limit, or let n approach infinity by taking the limit. Now, one thing that I want to do just notationally, because I don't really like the way that this looks, is we wrote this is the summation the whole time. Do we have a way to write the summation like really short and concise other than using sigma? Like maybe a letter and a subscript. I hear Angel saying it over and over. I just wanted to say it a little bit louder. S sub n, right? We're just finding the area for n rectangles. Okay, so all we have to do is take the limit of this. I'm going to say, now that we've named it S sub n to make sure that we're all on the same page, let's take the limit of S sub n. Let's do it. So we're going to take the limit as n approaches infinity of S sub n, which becomes the limit as n approaches infinity of what expression? Okay, nobody wanted to do any more simplification here. I'm going to do a simplification step right now. It's going to make the limit easier. We put it together, and I'm fine with that. I'm going to split it up again. What's 150n over n? Minus 150 over n. That's what this expression becomes, right? Now, if I want to take a limit, what's the first thing we always try? Should we just L'Hopital this right away? No. When can you use L'Hopital? 0 over 0 or infinity over infinity. Love it. Okay, so let's take this limit. What do we get? If we plug in, we try direct sub, and we put this to be infinity. What's infinity over infinity? So that's 0. So what do we have? 150. Now, because we were specifically asked to find an area, there is an appropriate label that needs to be on this. We don't know whether it's feet or meters or yards. We're told. All I know is they're units. And if it's an area, they're units squared. Now, this problem was long. We're going to do the exact same problem again, but part B is going to be with what? What was part A with? If you look all the way at the beginning of the problem, using left endpoints. Now, left is the intuitive choice. Unfortunately, left is also the wrong choice. Yesterday in our notes, we made a comment, and I just asked for whatever, and I might have alluded and tried to get you guys to see my side of it, and it was not intentional, just so you know. I lost my notes yesterday. Can I steal somebody who has good notes? And nice, do you take good notes?
Sure.
So will you guys look for me in your statement? Somewhere when we did the area, we made a comment about left endpoints, typically left endpoints. I don't know where it is. Aisha found it, and so did Leanne, it looks like. What's by it in your notes? Where do we say typically left endpoints? What's up? So even before this problem. It's somewhere in here, right? So using left endpoints, but we probably said something up in here. Does that say default? Yep. Can I steal your notes really quick? Is that okay? Okay. All right. So this, we're going to cross something out. I don't want you to erase it because it really doesn't matter which endpoints we use. But Leanne was kind enough to borrow her notes because I've lost mine through the internet, or I don't know how to say that. My computer's dumb. But if we look at this, here's 5.1.2, and holy dark. So turn that exposure up. Okay, we started with the area under the curve from A to B. And then right here is the comment that I'm referring to. We said delta x is b minus a over n. In each interval, there exists a rectangle whose area is this. And we make this comment, default to left point. I think that we should cross out left because based on how bad it was just now, not that you guys did poorly with it, and you will agree with this, we're just doing it early, cross out the word left and replace it with right, because we're going to do this problem again with right endpoints. And if you were feeling uncomfortable with what we've done so far, You will much prefer the right endpoints, I assure you, and we'll just make that change now. Okay, so we're going to do the exact same problem with our right endpoints. And for this, we have a couple of options. There's a few times throughout the year where I think it's beneficial. Like I always prefer the discussion-y side of stuff. But I really want you guys to, instead of saying, oh yeah, what approach would you take and would you take? I'd rather just say, here's the approach that you should take. And there's not many times that I like to do this and I say, hey guys, just let's watch how I start this. But hey guys, let's just watch how I start this. And I'll ask some questions of you, but I want to make sure that we can all have like a solid, nice approach to these problems. And I think the easiest way to do that is through demonstration stuff. Cool. So let's start with the right endpoints. And we'll do, or sorry, let's continue on. We just got the area was what? 150. So you guys will have to remind me of a few things. What's our function? 3x for x in 0 to 10. Is that true? Okay. And then we did left endpoints last time. We're going to use the right endpoints. Now, we will still, I'm not going to just make you listen to me for the next 10 minutes. Like I'm going to be asking you guys for some input and stuff, but I'm going to make sure that we do take the exact steps that I want. And we're going to write way less than we did yesterday. I assure you. If we want the area of the rectangles, and that's like our goal here, we only need 2 things, 3 things really, but we need delta x, we need f of c sub I and c sub I. So I would change the order of those, but I need those 3 things. Now, the nice thing is whether you're using left or right, not everything changes. Everything that we did in the last problem is going to show up here, but way easier. So let's start. Delta x, without just looking at the problem that we did yesterday and using the same number, how do we find delta x? Good. Now, on the other one, I wrote 10 minus 0 over n. I think we can probably just agree it's 10 over n. Now, when we go to our right endpoints, c sub I, the number line that we used yesterday, if it helps, I would encourage you to use these a little bit. But I'm going to say here's 0, and then I go 10 over n, and I get here to the next endpoint. Do you guys agree with that, whether you draw it or not? Yesterday, what was so gross about the left endpoints? If I wanted the left endpoint of the first interval, there was something goofy with the index. We had to do I minus 1 to get it to kick back, right? So we're going to generalize this a bit here, and we'll re-generalize it, and we will write this again. But yesterday, we just took the very leftmost point, and then we added a delta x times I minus 1. That's what we did. And if you look back at it, like I assure you, that's exactly what we did. Today, we don't have to worry about I minus 1. And it's so much nicer. So the generalized rule that we're going to follow, and again, we will make sure that this is written elsewhere also, but all we're really doing is for an interval a to b, we're taking a plus delta x times I. So if I want the first right endpoint, I just plug in 1, and it's now going to be 0 plus 10 over n, which is where the first right endpoint would be. I had that on the number line. So we plug this in, and I do 0 plus 10 over n I. Is there a better way I can write this? For sure, it's just get rid of the 0, right? So I'll even write c sub I one more time. 10 over n I. So already we're cooking so much faster because we're not doing all the wordy stuff. We have delta x. Good. I have c sub I. Good. What else do I need? Good. I have the width of every rectangle. I know where I need to plug it in. All we need left is f of c sub I. And let's just do this. It's 3 times, every x value is going to look the same depending on my index. What goes in here, Mickey? What goes inside of here? Good. Doable, right? Okay, so give me a more convenient way, knowing that we're going to be taking the limit of a sum, or we're going to be doing the sum is really the ugly part. What's the best way to write this? What's the only thing that's going to stay inside of my summation? I. So I would call this 30 over n I. And I would move it out here personally. Like this is how I would write it. Don't really care if you write it this way, but we should move the constant multiple outside of the summation. Do I have everything that I need at this point? I want you guys, was that way faster and easier? Now, really, it wasn't any different, except instead of I minus 1, we just use I. We just didn't talk through it all. What took us 25 minutes to get to yesterday just took us 3 minutes to get to here. And it will take you 3 minutes, and maybe I should have gone faster yesterday in hindsight. Your job right now is I want you to find S sub n with your neighbors, and I'll give you a head start. I'm going to say dot, 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 a whole bunch of math happens. And then once you get S sub n, you're going to take the limit as n approaches infinity of S sub n. And all of a sudden, these problems get so much faster. I'm going to give you guys like 4 minutes if I can find my other 4-minute timer, or I'll count 240 seconds if I have to. 1. Just kidding. So I'm back recording here. Up on the board, I have S sub n. Before we take the limit of S sub n, what questions do you guys have? Are there places where we did stuff different that you're not sure what I did? I feel silly because here I factored or I distributed, and then immediately on the next line I undistributed. And we'll see that there's a reason that I did that. In the end, we'll see that there's a really nice shortcut here. Anybody, no questions here? So when we take this limit then, and we'll just finish off this problem real quick, we get the limit as n approaches infinity, and I would rewrite this. I'm going to write this like we did the other one. Is it still going to be 150 plus 150 over n? Okay. So that's just me simplifying this last little thing like we did the other one. 150 plus 150 over n. And when we take this limit, what do we get? 150 what? Weird. Now, it didn't matter, apparently, whether we did the left or the right. The right is obviously going to seem like a million times easier because we didn't talk out any of the stuff, and it is a little bit easier. But I'll tell you, if you're comfortable getting delta x, getting c sub I and f of c sub I, or f of c sub I minus 1, it's like, honestly, it adds one step of algebra. We get the exact same answer. Because we get the exact same answer, can we all agree that there's a nicer endpoint to use? And what is the nicer endpoint? The right endpoint. Now, in the end, we're not going to have to do this again, and you guys, I think you can do this, so we can just listen. Was what we just did overkill for finding the area under that curve? Like, we're doing it to get practice with stuff, but Rafa, you said yes, I agree with you. Why do you think that it might have been overkill to do that? Okay. What did I graph? This is 3x till 10, right? What did we just find the area of? We found the area of a triangle is what we ultimately did. Now, again, we could have done this much easier than what we just did, but that's not the important part. The method is the important part. We can double check though. I got 150 for the left and 150 for the right. How do you find the area of a triangle? Base times height gives me a square times 1/2, or divided by 2. What's the base of this lovely triangle? Sure. Could it be 30? Okay. I'll call it 10 because that's the side that's on the bottom. What's the height of this triangle? And what's 10 times 30? And half of that, which is exactly what we got on both of our answers. Now, it's awesome, and 100%, if I was given this and all the directions said was find the area, there's literally a 0% chance that I would go through doing all those summations that we just did. However, we can do a problem where all of a sudden it's not a triangle and the technique doesn't change. Nothing changes about what we did other than I don't have a nice graph that I can just calculate it. Okay, should we do one ugly one together? Oh, that wasn't the like, they don't really get super ugly. Like, I'm speaking with a little bit of hyperbole. They don't get terrible for us. Integrals do get really hard on Reddit. I don't know what Reddit it is, and I'm going to talk about this like every day. Must be R Math is my guess, but they've started posting daily integrals that I can't do about half of them. they're hard. They're really hard. And I just used a word that I shouldn't have yet. That's okay. Let's do one more. Is this a together problem or a try it on your own problem? Okay. Use summations. And I don't care. Notice I didn't say left or right. I'm going to let you pick. Which one are you going to pick? Good choice. Use summations. Now, I could have just said use calc to find area. Now, if anybody's out there thinking, aha, I'll get you, Holloway, I'm not actually going to use calc. I'm just going to, nobody's thinking that, but let's just pretend that somebody is. Good luck is my follow-up. I don't think you'll be able to do this without using the calculus approach. So let's try it. I want the area under, and I'm not even going to say under. I'm just, if I say find the area, it's the area where, between what and what? Good, the function and the x-axis. So I'm not even going to say find area under the curve. I'm just going to say find area. And I'll use a colon, and we'll just say f of x is equal to, I don't know, let's call it 16 minus x squared. And we'll go ahead and let our x be in the closed interval from 0 to 4. Okay. I'm going to do this problem very similarly to the last one. I'm going to give you guys a couple minute head start. I'll get some chill tunes going so it's not just blank silence in here. It makes me uncomfortable. But I want you guys to get started on this. I'll give you a head start, and I'll start working it here momentarily. If you're on the road and watching this, please pause it and try it. If you're struggling to get started, I want to remind you, right endpoints are the thing to use. And every time you do these problems, the first 3 things that you need to work out are your delta x, your c sub i's, and your f of c sub i's. This is our starting point. So pause the video now if you're watching it, and I will see you guys. I won't really see you, but you'll see detailed work on this in 3, 2, 1. Love it. Okay, so delta x, b minus a over n gives us 4 over n. C sub I will look like a plus delta x, since we're using our right endpoints. What's a in our situation? So 0 plus 4 over n would give me 4 over n. And I'm going to do this one just a little bit faster. If I do 16 minus 4 over n squared, I'm going to get 16 minus 16 over n squared. Am I wrong? Oh, man, what did they do? Are we better now? So and then what goes here then? I squared. Cool. At this point, we are pretty solid with it. We just need to start working out what? So I heard solution. You're kind of right. Did you not say solution? You said summation. That's a very similar word. Okay, let's do S sub n. Let's find it. Okay, what's the sum we do from n equals, dang it, from I equals 1 to where? Indeed. Do you want me to do it in multiple steps, or can I do it as if I was just doing this problem by myself? We'll do little steps. We'll meet in the middle. Here's my delta, or my f of c sub I, 16 over n squared I squared. And delta x is what? 4 over n. Okay, if you're getting hung up on the algebra here, and I know that at least one person did, but my suggestion, if you have the chance to clean it up here, I would just do it up here rather than doing it in the summation. Realistically, if you wanted to do all of f of c sub I times delta x and then write your summation after you figured out what it is, you can, as long as we get the right thing inside of the sum in the end, it's okay. But if we're doing it here, what's the next thing you guys would do? Good. I think I heard somebody quietly whisper distribute. 48 over n. Ooh, 64 is 4 times 16. That's true. 64 over n minus 16 over what? No, it's still 64, isn't it? What is this guy doing? Louder, Angel. And cubed, and finally, I squared. Okay, so we have all this. Now, these ones, I do not remember most of them off the top of my head. I'm going to be honest. I remember the sum of I, and I don't know that I remember the other one off the top of my head. N plus 1 and 2n plus 1 over 6, but I think there's a square or something somewhere. I don't know. I don't recall them yet. N times n plus 1 times 2n plus 1 over 6? Okay, cool. Took me 2 tries, but we got it. Okay, so here we go. We're just going to keep kicking. Can I split these sums up pretty easily? And let me rephrase that. Am I allowed to use this thought? The sum of a difference. Like, am I allowed to use that here? Yes, I see confident, quiet nods. I agree. So let's finish this one problem really quick then. I'm going to do something a little bit different, and I want you to see if we probably didn't write this the same way, but this is how I do this problem. Minus 64 over n cubed times the sum from I equals 1 to n of I squared. The right sum, or sorry, this sum right here is the weird one. I have nothing inside of it. When I don't have an argument to my sum, just like when we don't write numbers elsewhere, what do you think the argument is? It's a 1, and we can write the 1 there. It's more proper to write the 1. We could have kept the 64n, or 64 inside, and then just done the same thing. This is how I view this, though. So we get 64 over n times, what's this sum become? Just n. Yeah. Minus 64 over n cubed, and this one is n times n plus 1 times 2n plus 1 over 6. Now, for this, I'm going to keep you guys like 60 extra seconds. I just want to talk about this last part. Once I get here, you're going to see, and we'll do more of this on Monday, this one's 64 for sure. Minus, here's the weird thing that I do, and I want you, I'll show you the homework. You are going to have homework. I'm going to keep you a minute longer. If I don't want to FOIL all of this stuff out, I would like to avoid it. Do you guys agree that everything is going to be over n cubed in the end? And when I take the limit here in a minute, anything that's smaller than n cubed divided by n squared, it's going to fall out, right? So when you were doing these, we don't have to FOIL everything. I'm only going to get one n cubed term out of this numerator, and it's going to be 2n cubed. Everything else that shows up, I can see is going to be divided by n cubed, and it's going to disappear at the limit. So this is a very informal thing, but I physically do this. There's a bunch of other stuff that shows up here. I don't need to write it because it's all going to fall out. Over 6, your job this weekend. I want you to finish this. You should confirm to me that you get what for this one? 64. And then beyond that, I want you guys to do this assignment over the weekend. Cool. I'll post it on the classroom. If you want to peace out so you're not late to class, you can get it from there. If you want to take a picture of it after you grab your phone, that's fine with me.